Bismillahirrahmanirrahim. Assalamu alaikum everyone. I hope you guys will be good by the mercy of Allah. So today the topic that I'm going to present here is Camosmosis, and my name is Muhammad Abu Bakr. So what is the Camosmosis? Most of the guys from you are aware about Camosmosis. And the Chemiosmosis, what is the Chemiosmosis? What happens in the Chemiosmosis? One term is osmosis, and when the word chemi just attached with that osmosis word, so it means that there is a process happening here. The chemical process is happening here. That's why the name you are seeing here, the Chemiosmosis. So let me guide you how the chemiosis works. What is chemiosmosis? And who just gave the idea of the chemiosmosis. So the chemiosmosis is the movement of ions across a selectively permeable membrane down their electrochemical gradient. So the more specifically it relates to the generation of ATP by the movement of hydrogen ions across the membrane. What happens here? The movement of hydrogen ions is happening, and by the movement of the hydrogen ions the generation of ATP occurs. So the hydrogen ions are moving from the region of high concentration to the region of low concentration, and the ATP synthase complex is used for the synthesis of ATP in chemiosmosis. So here in this picture we can see that we have two different regions. One is the highly concentrated region, the high ion concentration, and the second one is the low ion concentration. And we know this thing that the molecules or the things moves from the higher concentration to the lower concentration. The most common method involving chemiosmosis is the production of ATP during last step of cellular respiration in electron transport chain. So in the last step of the electron transport chain, we can see that the process of chemiosmosis is happening, and the generation and the production of the ATP is happening. So it takes place in the mitochondria because enzymes of electron transport chain are embedded in inner mitochondrial membrane. The Chemiosmotic Theory. Who was the person who just gave the idea about that? Who was the person who suggested the hypothesis? So here is that person. And the name of that person, you can see that it's Peter D. Mitchell. That was the person who proposed the chemiosmotic hypothesis in 1961. Where it occurs in mitochondria and chloroplast. So this theory suggests that the energy of NADH and FADH2 used for the ATP synthesis in respiring cycle, or the respiring cell, So these protons move across the inner mitochondrial membrane by using energy of electrons from electron transport chain. The protons, the hydrogen ions, flow back to the matrix through ATP synthase and provide enough energy for ADP to combine with inorganic phosphate to form ATP. So the ADP and phosphate molecules, and they are coming together, they are generating the ATP molecule. So the electrons and the protons at the last pump of electron transport chain are taken up by oxygen and to form water molecule. So here is the procedure, here is the process that's happening. Here we have the electron transport system. So in this system we can see that, as we have studied previously, that we are getting the energy through NADH and FADH2. So what's going on there? Right here we can see that the electrons are moving through the complexes, through the coenzyme, through the cytochrome, and these electrons, when they are just moving from the last complex, when the electrons are coming down, so below that right here we have the oxygen molecule, and we can see that the hydrogens are always present here and they are already here. So these hydrogen molecules and oxygen molecules, when they interact each other, so they are going to generate a molecule of H2O, the water molecule, and that water molecule is used in the metabolism. So on the right side you can see that there is the ATP synthase complex. So in this complex, this is the complex by which the generation of ATP is happening, and by this complex we can study the chemiosmosis. We can see that in this slide on the right side, the ATP synthase complex. We have two different regions. One is the upper region. In the upper region we can say this complex, this region, to F0 region or F0 complex, and the lower region to F1 complex. In the F1 complex we have alpha 3 beta 3 hexamers, and in between F1 and F0 region we have gamma epsilon. That gamma epsilon rotates, and when it rotates the hydrogen molecules comes down and the ATP molecule generates. So what happens? On the top we have C. In the F0 region we have C subunit and A subunit, and they both are attached. In the C subunit we have two half-filled channels. One is opening in the inner mitochondrial space, inner membrane space, and the other one is opening outside. So what happens? The hydrogen ions are moving from high concentration to that half channel, and in that half channel we have aspartate 61 molecule. So we can see that here we have the F0 region, F1 region, and the gamma epsilon. The hydrogen molecule is entering in the half channel. Right there we have aspartate 61, and when the hydrogen molecule comes towards aspartate 61, that aspartate 61 is being converted to the aspartic acid, and after that the hydrogen ion moves down to the alpha 3 beta 3 hexamer, and after passing from the alpha 3 beta 3 hexamer the ATP molecule generates. Here is the ATP synthase. The ATP synthase, the enzyme that catalyzes the ATP synthesis. So the ATP synthase has two units. It's F1 unit, as I told you, and F0 unit. In the F1 region, it projects into matrix, has 3 alpha, 3 beta, gamma, delta, epsilon chain. It catalyzes the ATP synthesis. The catalytic sites are present on the beta subunits. And the F0 region, it's embedded in the membrane. It acts as a channel for the transport of hydrogen ion. So right here you can see that we have 3 different structures, and in these 3 structures you can see that the beta 3 hexamer, each structure is presenting the beta 3 hexamer. First of all, we're going to talk about to the very left sided beta subunit. In the beta subunit, beta 3 hexamer, alpha 3 beta 3 hexamer, we have three beta subunits. One is the open form, one is the loose form, and one is the tight form. What happens? The ADP molecule and the phosphate molecule enters in the open form. After that, when the gamma epsilon rotates, after that they converts to they comes to the loose subunit. In the loose subunits, they are bringing close to each other, and when it rotates again, it moves to the tight state, and right there the generation of ATP molecule occurs. And when it moves in the clockwise direction, the alpha 3 beta 3 hexamer, the open side comes down and the generation of ADP molecule occurs, and again the process repeats. ADP and phosphate molecule enters, it comes to the loose state, and after that it comes to the tight state. So these are the subunits. These are the subunits for ADP synthase complex. The C subunit, the A subunit, the alpha 3 beta 3 hexamer. You can see that the alpha and the alpha 3 beta 3 hexamers are attached to each other. It means the alpha 3 beta 3 hexamer is not rotating. The thing that is rotating is the gamma epsilon. So you can read that the beta, the ADP and phosphate binding in the beta, and in the alpha linked beta subunits can bind ATP, and the gamma rotates to change alpha and beta conformations. In the C section, in the C subunit, it contains proton half channels, and in the A side, the A channel is a site for proton entry into C subunits. So here is the mechanism of ADP synthesis. So the three beta subunits change conformations during catalysis, with only one beta subunit acting as catalytic site. So beta subunit occurs in three forms. The open form, it has low affinity for substrate, ADP and phosphate molecule. L form, loose form, can bind substrates, ADP and phosphate, but catalytically it is inactive. T form, the tight form, it binds substrates, ADP and phosphate tightly and catalyzes the ADP synthesis. When the proton passes through the disk of C subunits of F0 region, it causes rotation of gamma subunit. The B subunit, which are fixed to the membrane, do not rotate. The ADP and phosphate are taken up sequentially by the beta subunits, which undergo conformational changes and form ATP molecule. So here you can see the structures, the different shapes. When the open form comes, the ADP and phosphate molecules goes in, and when the loose form, it changes its shape, and in the tight form it generates ADP, and again the molecule of ADP is going out, and again the ADP and phosphate molecule are entering in the open state. So here we can see that the gamma subunit is in the form of axial. It rotates when protons flow. When proton enters, it rotates, and the generation of ADP process occurs, and the ADP synthase is smallest known molecular motor in the living cell. So it is a motor by which the generation of ATP occurs, and by this motor the process of chemiosmosis is happening. So that's all from my side. Thank you so much for your time. Have a blessed day.